Hi, and welcome to this section of the class where we're going to continue working with fractions. We're going to continue learning how to add and subtract fractions, but this time the problems are going to be a little bit more difficult in the way that the denominators are set up. So in the previous section we said that in order to add or subtract fractions, the denominator, which is that bottom number, has to be the same. It's the only way you can do it. If they're not the same, we have to do a little bit of work first. It's not going to be hard. We have to do a little bit of work. And so here in this section, we're going to talk about those kinds of problems, and we're going to learn how to do that. So let's go ahead and, like I like to start these sections out, draw some pictures and understand what we're doing. Let's say you have a pie here, okay, and here's half of a pie. We said this is half, one piece out of two possible pieces, okay? Now let's say over here, I want to add something to it. So I'm going to end up adding something here. But what I'm going to add, okay, is not going to be a half. It's going to be 1/4. Okay? One piece out of four possible pieces. Now, question is, how do you do this? You don't know how to do this because the denominator is not equal. The denominator is not equal. Okay? This number is not the same as this number. We said in order to add or subtract fractions, the bottom numbers have to be equal. In this case, they're not equal. So what do you do? Well, I'm going to show you what to do, and it's going to be really cool. It may seem a little bit confusing at first, but I promise you it's going to be better. What we're going to do is we're going to change this problem, okay? So this was our original problem, okay? This was our original problem. But what we're going to do is we're going to change the problem a little bit, and we're going to make it so that these bottom numbers are the same. How do you think we can do that? Well, let's go ahead and let's change this first fraction a little bit. Just stay with me. I promise you, you will understand this. Okay? This is half of a pie. Okay? And we all know that. We can cut it in half. But let's go ahead and cut it into 4 pieces instead of in 2 pieces. And then what if we took this piece away here and this piece away here? Okay? What would we have here? Okay? Well, we would have 2 pieces out of a possible 4 pieces. So we would have 2 out of a possible 4 pieces. 2 out of a possible 4 pieces. Okay? Now, what if we just left this part the same as in our original problem, and we would have 1 piece here out of a possible 4 pieces, so this would be 1/4, 1 piece out of a possible 4 pieces. Now I'm asking you the following. I tell you that these 2 problems are exactly the same, okay? I mean, when you look at it, here I have this much pie, and here I have the same amount of pie. Here I have this much pie, I have the same amount of pie. So in terms of pie, in terms of how much pie is on the table, it's the same, okay? This is the same amount of pie as this, even though the fraction looks a little bit different. And this is exactly what I was telling you before. Fractions can look a little bit different, but they might be the same, and that's why we always simplify things. If you were to try to simplify this fraction, divide the top by 2 and the bottom by 2, you would get 1/2, which is what this fraction is. All I'm telling you is I'm writing this fraction in a different way. The reason I did that, can you guess why I did that? I did it because I want these 2 bottom numbers to be the same. Then I can add these fractions together. That is the secret to adding fractions. You want to change the problem so that the bottom numbers are equal. That is the only reason we did this. Otherwise, there'd be no reason to do it. Okay? So, if we did this, if I took this and added it to this in picture form, okay, I would have this pie cut into 4 pieces. I'd have this piece from over here. Okay, and then this half of the pie over here, I'd have a piece here, and I'd have a piece here. So I'd have 3 pieces out of a possible 4 pieces. 3 pieces out of possible 4 pieces. And notice, that makes absolute sense with my rules. The bottom numbers are the same, so I keep my bottom number. The top number, I just add to each other, and I get 3/4. 2 plus 1 gives me 3. Okay, so as we go farther along, we're not going to have to draw all this stuff every time, but I'm just showing you what we're doing. We're taking a problem that has different denominators, and we're changing it. The only thing we did is we just changed the way the fraction looked. The only reason we did that was to get the bottom numbers the same, then we can add our fractions. And we do that using the same method that we learned in the last problem, in the last section. Okay? So once you know how to change the fractions to get it into the right form, then you can go from there. Now this whole process is called finding the common denominator. What you want to do is you want to find a denominator between the two fractions and make them the same. Then you can add them or subtract them. That's called finding a common denominator. Okay, now I've set another problem up on the board, and what I want you to do is ignore this and just look at the top part of the screen for a second. Here I have a pie. I divided into 8 pieces, okay? 8 pieces. I have 7 of the 8 pieces here, 7/8, okay? Now what I want to do is subtract from it another pie, and this one is 3/4. 1, 2, 3 pieces out of 4. How would you do that? Well, the first thing you know is that the bottom numbers, the denominators, are not the same, so you can't subtract them. So that's why I have here the denominators aren't equal. You don't know how to do that. So what we're going to do is we're going to change the problem into what I have down here, and that's what this arrow means. I'm going to keep this top one the same, 7 pieces out of 8, that's 7/8. And what we're going to do is we're going to change this problem. We're going to make a pie with 8 pieces, and we're going to shade 1, 2, 3, 4, 5, 6 pieces, 6/8. Now one thing I want to tell you is that even though this fraction looks different than this one, this is the same amount of pie as this, and you can kind of see that. Here's this much pie and here's this much pie. Even though it's a different fraction and it looks a little bit different, it represents the same amount of pie. And you could see that if you were to simplify this fraction. 6 divided by 2 would give you 3, 8 divided by 2 would give you 4. It's the same amount of pie in each case, okay? So now that we have this new problem transformed here, we can actually do the subtraction. 8 is the same number as 8, and that's what allows us to go ahead and move forward, and that's why we did this in the first place. Okay? But if we were going to have 7 pieces out of 8 and subtract 6 pieces, well, how many pieces will we have? 7 pieces here, and there's 6 pieces I'm taking away, so all that I'm going to have left, okay, over here, is just going to be 1 piece of pie. Because here I had 7 pieces out of 8, and I'm taking away 6 pieces. So I'm only going to have 1 piece out of 8. And that makes a lot of sense when you look at how I taught you how to subtract fractions. The bottom number is the same, so I keep it here. The top number, you take 7 minus 6, and you get your 1 piece. So that was a problem where we found the common denominator in order to subtract a fraction. Now, up to this point, I've been drawing a lot of pictures and showing you and proving to you that what you're getting here is the same fraction, and so we can go ahead and move forward. From now on, we're not going to draw any more pictures, and I'm going to show you how to do this common denominator stuff in your sleep. What if you have 1/2 plus 1/6? First thing you need to say is, are these two numbers the same? No, they're not. So you have to do something to them in order to be able to add the numbers, okay, to add the fractions. I told you before you can do the same thing to the top of a fraction and the bottom of the fraction as long as you do the same thing. So let's go ahead and do that now. What if we multiplied the top of this fraction by 3 and the bottom of the fraction by 3? We're doing the same thing to the top and the bottom, so we're not doing anything illegal. But let's see what that would give us. What this would do would be 1 times 3 would give me 3, 2 times 3 would give me 6. And then if we're going to continue to add the 1/6, you see what we have done is we've changed the problem into a problem. Now we have the same bottom numbers, and we can go ahead and continue. Since the bottom is the same, we just keep it as a 6. 3 plus 1 is 4, and we've done that before. And here, it just becomes the same old stuff as last time. You always check, can I simplify this? Sure I can. I can divide the top by 2 and the bottom by 2. And that will simplify this fraction. 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. So the answer is going to be 2/3. Now that looks pretty complicated, but just remember, what you're going to end up doing anytime you have two fractions that look different in the bottom, try to find a number that you can multiply both top and bottom to make the bottom number the same as this one. And then go ahead and write that down, and then the problem becomes the same as before. there's only one more step added. You have to multiply the fractions in order to get a numerator, denominators that are the same. Every now and then you'll have to multiply both fractions by something to do this, but for these problems here, we're going to keep it simpler. Let's work some more problems. I think you'll get the hang of this. 3/8 plus 1/16. 1/16, okay? What can I multiply this fraction by that would give me a 16 on the bottom? Well, I know that 8 times 2 is 16, okay? So 8 times 2 is 16. I got to do the same thing to the top, okay? So what's my new problem going to be? 3 times 2 is going to give me 6. 8 times 2 is going to give me 16. And of course, I'm adding to it 1/16, okay? And so now the bottoms are the same, so I can just keep it just like before, and then 6 plus 1 gives me 7. 7/16. And there's nothing I can do here to simplify that anymore. Okay? We're just going to work a lot of these problems. 7/8 plus, let's go ahead and do minus 1/2, just to go ahead and give you a flavor for that. Now, what can I do to make these two fractions have the same bottom? Well, I know I can multiply this bottom number by 4, okay, and that would give me 8. That's what I'm trying to match, okay? So I have to do the same thing to the top and the bottom, okay? So what I'm going to have in the end is I'm going to have 7/8, because I didn't do anything to that, minus, on the top I have 1 times 4, gives me 4, and on the bottom I have 2 times 4, and that gives me 8, okay? So at the end of the day, I'm going to have the bottom number is the same, so I keep it. The top number is 7 minus 4. Subtract, you get your 3. 3/8. Okay? Not that hard, especially if you have mastered how to add fractions from the previous section. You're only doing one more step, and that is finding that common denominator. You just have to pick a number, multiply top and bottom, and go from there. What if you have 9/10 minus 1/5? Okay? Well, 9/10 minus 1/5. I know that I can multiply this number times 2, and that'll give me a 10. So we're going to change the problem. Okay, and what we're going to do is we're going to multiply the bottom times 2 and the top times 2. Why are we doing that? Because we want to try to make the bottom of this equal to 10. 1 times 2 gives me 2. 5 times 2 gives me 10. Now our problem has the same denominator. We can go forward. Keep the bottom. Don't do anything different. 9 minus 2, you're going to find that that's going to give you 7. So the answer is 7/10. Okay? What if you had 2/3 minus 1/2? 2/3 minus 1/2. Well, here, this problem is a little bit trickier because there's nothing I can, there's nothing I can multiply this bottom number to give me a 2, and there's nothing I can multiply this bottom number to give me a 3. So I'm not going to be able to just multiply one fraction, but what I know that I can do is, just follow along with me here. If I multiply this guy by 2, and of course do the same thing by the top, and then if I can do the same thing to the other fraction, but pick a different number, I can multiply this by 3 and this by 3. Let me go ahead and make this clear. Multiply this by 3. I'm going to come back and explain everything in a minute, but let's go ahead and figure out what that would do. 2 times 2 would give us 4. 2 times 3 would give us 6, and I'm subtracting. Here, 1 times 3 would give me 3. 2 times 3 would give me 6. Now look at what I've done. I have the same common denominator, and I can go ahead and finish the problem. Okay? So let's go ahead and do that. In the bottom you have a 6. In the top you have 4 minus 3 gives you 1. So that's the answer. What I want to show you here is that you don't have to multiply both fractions by the same number. All you have to do is make sure the top and the bottom are multiplied by the same number here, and the top and the bottom are multiplied by the same number here. So a guaranteed way to get a common denominator is just multiply by the other denominator. 2 over 2, and then here multiply by the other denominator, 3 over 3. And when I did that, I knew that 2 times 3 was going to give me 6, and I knew that 2 times 3 was going to give me 6. So I picked my numbers so that my common denominator is now 6. Then I could finish solving the problem. Let's do a couple more problems, and I think you'll get the hang of this. 3/4 minus 1/3. Again, there's no single number I can multiply by that'll make this bottom a 3, and there's nothing I can multiply this by, this bottom number, to give me a 4. So I'm going to have to multiply both fractions by something. And it doesn't have to be the same number. What I'm going to do is I'm going to multiply this by this denominator over here. It's going to be a 3, and I've got to do it to the top. And then here I'm going to multiply this by this denominator, which is going to give me a 4. Okay? So all I'm doing is I'm multiplying the fractions by the other denominator. And let's see what that will do. Okay? Let's see what that will do. 3 times 3 is going to give me 9. 3 times 4 is going to give me 12. Subtracting, top is going to be 1 times 4 is going to give me 4. Bottom, 3 times 4 is going to give me 12. So you see, what we've done is we've changed this problem. Now we have the same common denominator. So the bottom's going to be 12, and the top's going to be 9 minus 4, which is going to give you 5/12, and that's the final answer. So the trick here is if you can't figure out what number to use, just multiply this fraction by the denominator of this one, and multiply this fraction by the denominator of that one. Doing that will always make sure that you have, in this case, for instance, 3 times 4 gave me 12. Here, 4 times 3 gave me 12. All I care about is that the denominator is the same. I really don't care what I multiply by. That can be anything. I just want to make sure that in the end my denominators are the same. That's all I'm trying to do. Okay? So it may take you a few tries to figure out what to multiply by, but once you get it, then the problem's simple. Let's say 1/6 plus 1/8. Again, I'm trying to find a number that I can multiply these fractions by to give me a common denominator. Well, I'm just going to go ahead and, by example, multiply this guy by 4 and this guy by 4. That's going to give me 6 times 4 is 24, okay? Now I know that 8 times 3 is also 24, so I'm going to go ahead and use that one and multiply by 3. The reason I did this is because I want to make 24 in the bottom over here and 24 in the bottom over here. 4 times 6, 24. 8 times 3 is 24. Okay? So let's go ahead and do this. 4 times 1 gives me 4. 4 times 6 gives me 24. 1 times 3 gives me 3. 8 times 3 gives me 24. So I've done what I want to do. I've got the same common denominator. So I keep 24 in the bottom. Don't change that. 4 plus 3 gives me 7. So the answer is 7/24. So it may take you a minute to pick something, and it takes practice, that's why I'm doing these, to pick something that's going to be able to give you a common denominator. Last problem we're going to do is 3/10 plus 1/3. Okay? Again, different denominators, so we're going to have to do something. What I'm going to do is, I know that 10 times 3 is going to give me 30, so I'm going to do this. So 30 will eventually be over here. And then if I take 3 and multiply times 10, that will also give me 30. So that's going to be my common denominator. 3 times 3 in the top gives me a 9. 3 times 10 gives me a 30. And I'm adding to it 1 times 10 gives me 10. And 3 times 10 also gives me 30. So you see I picked my numbers here. Here I multiplied by the other denominator here, and this one I multiplied by the other denominator. And that tells me that I'm always going to have a common denominator here, because 3 times 10 gives me 30, and 10 times 3 gives me 30 here. So in the final answer, you just leave 30 in the bottom. 9 plus 10 gives me 19, which you can't simplify anymore. So adding and subtracting fractions when you don't have a common denominator isn't really that hard. You just need to work with the fractions ahead of time to make the denominator equal. And the way you do that is you pick numbers that you can multiply the top and the bottom by in order to change that bottom number into what you want. And then if you may have to do it to 2 fractions in order to get both fractions to have the same common denominator. And then once you have the same common denominator, you just add them up and keep the same bottom. And that is how you add and subtract fractions when you don't have a common denominator.